Often lottery winnings are divided into equal payments given annually for 20 to 25 years. So the present value of the winnings is worth less than the actual jackpot, depending on the rate at which the money can be invested. Find the present value below. These are essentially two separate problems. Let's consider the first line, say that to be the A part. I'll do the A part first, and then we'll work the B part really as just a totally separate problem. In the A part, the jackpot amount is $12 million at an interest rate of 7%. It's done annually, so that'd be 7% compounded annually. 20 equal payments once a year, so that'd be 20 years. And we want to find the present value in dollars. So first of all, we're going to use the present value formula to find the present value. And our first task is to decide what each of these letters is, each of these stand for. P, of course, is the present value, and that's what they're asking us to find. So that is what we're searching for here in this problem. The periodic payment is not given directly, but what it says is the lottery winnings are divided into equal payments. And so if you win a certain amount of money, they're going to pay it out over either 20, maybe in these two cases 20 or 25 years. And the problem we're working, they're going to divide it out over 20 years. So they didn't exactly tell you the periodic payment, but they did tell you in the problem that the winnings are divided into these equal annual payments. So if you had $12 million as the jackpot amount, and you paid it out in equal payments, then you can easily see that you would take 12 million and divide it by how many equal payments there are, one a year, to figure out what the periodic payment was. So here they didn't exactly tell you the periodic payment, but they told you how to calculate the periodic payment. Now on your calculator you can do that pretty easily and figure out that that comes out to be $600,000. So as it turns out, the periodic payment is $600,000. The time in this particular problem is 20 years, 20 equal annual payments, that'd be 20 years. The interest rate, as we said, is 7%, which is 0.07 is a decimal. It's compounded annually, so M is 1. The interest rate per period, little I, is little r, which is 0.07, divided by M, which is 1. So whenever M is equal to 1, little I and little r are the same thing. And as you can see, if M is 1, little n and little t are the same thing as well. So now we've figured out every number that we need to plug into the formula. So let's do that. We're looking for the present value. So I will put a value in for R, which I've already decided is 600,000. 600,000. Then I've got 1 minus the quantity 1 plus little I, which I've calculated to be 0.07, raised to the negative n power, and I've calculated n to be 20, so that'd be the negative 20th power. And then that entire numerator is divided by little I, which again is 0.07. And now it just becomes a calculator problem. So the present value is 600,000 times. Now I'm going to do this calculation on the calculator. So I'll put it here where you can see what I'm doing. So I'm going to start off here. 1 plus 0.07, you can do it on the calculator or just realize that that's going to be 1.07, raised to the power of negative 20. So you have the power key. You can't put a negative number directly into the calculator, so the trick is to put in the positive value 20, and there's a key with a plus minus on it, and that changes the sign of a plus to a negative. So now I have negative 20 as the exponent, so I hit equal. That is the base raised to the power. But notice it's negative. It's not negative in the calculator, but I can make it negative by hitting the plus minus key. Now you can see that it's negative. And the only thing in the numerator that I haven't dealt with is this positive 1. So if I do plus 1 equal, that gives me the entire numerator. That needs to be divided by little I, which is 0.07. So I do divided by 0.07 equals. So the entire fraction there is equal to what's in the display of the calculator, which is, and I'll transfer it down here, 10.59401425. As I've said before, if you're going to take this number out of the calculator and put it back in later, take lots of decimal places, more maybe even than you think you need, but my recommendation is never to let it leave the display of the calculator, and then it doesn't matter. So taking the number in the display and multiplying it by 600,000, we get the present value, which is 635,6408, and to the nearest cent would be 55 cents. Now, sometimes that would be, of course, $6,356,408.55. Sometimes the problem asks you to round it off to the nearest cent. Sometimes it asks you to round it off to the nearest dollar. Let's just assume that they wanted it to the nearest dollar here. If you did, 55 is more than halfway, so at the 8 would go to a 9. So if you did want it to the nearest dollar instead of the nearest cent, it would be $6,356,408. $409 to the nearest dollar. And the original answer is to the nearest cent. So pay close attention to how they ask you to leave the answer, because it does matter. Now the B part is exactly the same calculation, except we replace the interest rate 7% with a 12%, and the equal payments are 25 over 25 years instead of 20. So I want to go through this same calculation again, but the process is exactly the same. So looking back at what we did earlier, the only difference when I'm doing part B is that the interest rate is going to be 12%, which is .12, and since I'm dividing by 20, the 12 million is the same, but since I'm dividing by 25 years instead of 20, then that becomes 25. And if I take 12 million and divide by 25, and you can do that on the calculator if you don't believe me, but you come out with $480,000. So that 600,000 changes to 480,000. Otherwise, the problem is exactly the same. So I wanted to go back and just kind of make the changes on here. It's still compounded annually. The time in years is 25 instead of 20. I'm still looking for the present value. The little I is still R over M, but since R changed, I've got to change that to 0.12 divided by 1, which comes out to be 0.12. And since now I'm doing it 25 years instead of 20 years, that 20 becomes 25, and that 20 becomes 25. So When you're doing it yourself, you probably don't want to go through and making a mess of your work. You probably just want to show it twice. But I did this purposefully to just show you that the idea is the same. You're just changing a few numbers. In fact, you're changing the interest rate and the number of annual payments. Beyond that, it's exactly the same problem. So when you go down here to plug in your values, the capital R, like I said, changed to 480,000. Then you've got 1 minus the quantity 1 plus little I, which changed, if you remember, to 0.12. And that's raised the negative n power. And remember, n changed to 25. So it'll be negative 25 divided by little I, which is 0.12. So as before, it strictly becomes an arithmetic problem now. So when I calculate the present value, I'm going to take 480,000 and multiply it by whatever I get as the value of this fraction. So as before, I will go here and do the arithmetic. 1 plus 0.12 is going to be 1.12, or you can just do that on your calculator. You're going to raise it to the negative 25th power. So you've got power button. Again, you can't put in a negative number directly, so you put in the positive value and hit the plus minus key. Now that's the power I want, so you're ready to hit equal. That's the entire base to the power, but it's negative. Up here it's positive, so I can use the plus minus key to include that sign, making negative. And the only thing in the numerator that I haven't considered is this positive 1, so I do plus 1 equals. Now that I have the entire numerator, I want to divide it by the denominator of 0.12. So that's the value in the brackets there of that entire fraction. So that's 7.843139.112. Carry lots of decimal places, but as I said earlier, as long as you leave the number inside the calculator display, that's automatically done anyway. So all I need to do now is multiply it by $480,000. And that gives me a present value of 3,764,706.77, and that's to the nearest cent. As I said earlier, sometimes they ask you to round to the nearest dollar, so if they did that, you would say, well, that would be 7 is more than 5, so it's 5 or more, I should say. So that 6 goes up to 7. So it'd be 3,764,707 to the nearest dollar. So that'd be $3,764,007 to the nearest dollar. And they have been known to ask you to round things to the nearest $100. The nearest $100 would be 707 is closer to 700 than 800, so it would just be $3,764,700 if they said to the nearest 100. Just be really careful about how they're asking you to round your final answer.